Hi everyone. So in the last video you learned about the convolutional encoding using time domain approach, right, or time based approach. Here you are going to learn the same convolutional encoding but using transform based approach, okay, or frequency based approach or frequency domain approach. This approach actually represents that you need to express each of these generator sequence in terms of its polynomials. Every sequence that you see here can be expressed in terms of the polynomials, just like how you learned in the cyclic codes. The same thing can be applied in the case of a convolution encoding, and that approach, that is representing every sequence in terms of polynomials, is called as the transform based approach or frequency based or frequency domain approach. So here the question again, the question is exactly the same. Construct a 213 convolution encoder whose generator sequences are given by g of 1 is equal to 1011 and g of 2 is equal to 1111, and also find its output when the information sequence is u is equal to 10111. Okay, so as usual, the first thing I'm going to do is I'm going to draw the encoder. I have already drew it in the last video, but I've explained that process again. So here it is 213. So you see, so which means the value of small letter n is equal to 2, the value of small letter k is equal to 1, and the value of small letter m is equal to 3. NKM convolution encoder. So here the number of output bit is 2. So what I'm going to do is I'm going to draw 2 output signals over here. And since there are 2 output signals, I might need 2 XOR function, okay? Not necessarily, but it depends. If there is only one connection, then you don't need an XOR function. Okay, so anyway, I'll just draw 2 XOR function over here, and I will connect those 2 XOR function to the output signal. Okay, right. Now next is, how many input bit is there? Only one input signal, right? Only one input bit. So I will draw that over here. This is the input bit. Okay, this is the input bit and this is the output. Okay, this is V of 1 and this is V of 2, and this is called as V, right? And this is called as U. This is the input, this is 2 output. And how many shift register blocks will there be? There will be 3 of them. So I'm going to draw them, the 3 of them, like this. 1, 2 and 3. That's it. Okay, the 3 shift register blocks. Now next, the connection between this and the output is what is being represented by the generated sequences. Okay, so here this represents the V of 1, and the connection of V of 1 is represented by the G of 1 sequence, and this is the second output V of 2, and the connection of this is represented by the generator sequence G of 2. Okay, so let's see, this is 1011. So 1 means there's a connection, 0 means there's no connection. You see, 1011. So it is 1, 0 means no connection, 1 and 1. 1 0 1 1. Okay, this means that the constraint length, capital K, the constraint length is equal to 1 2 3 4. The constraint length is equal to 4. Okay, like as we have already explained this in the last video, the previous video, that is this can also be represented as K by N comma capital letter K. You can write like this. Okay, what is K? 1 by 2. So this convolution encode is also called as 1 by 2 comma K is equal to 4 convolution encoder. Okay, so either in the exam, either they'll give you 213 convolution encoder, or they will say like this: 1 by 2 comma K is equal to 4, capital K is equal to 4, which means the value of K is equal to 1, the value of N is equal to 2, and the value of capital K, that's the constraint length, is equal to 4. 4 means there are 4 shifted versions. There's this one, the one without any shifted version, then after one shift, after the second shift, and after third shift. Therefore 1 2 3 4. That's what it means. This is called as a constraint length. So they'll write like that also. Okay, so anyway, so this is the connection. That's it. This is the sequence for G of 1. Now what about G of 2? G of 2 means 1 1 1 1, which means there's connection from here, here, here and here. From all the 4 positions, there's a connection to the output. So we'll draw like that. This is it. Okay, 1 1 1 1 1 1 1 1. This is how we draw the 213 convolution encoder. Okay, so now what I'm going to do is I'm going to apply convolution encoding. Okay, I'm going to apply convolution encoding using transform domain approach or transform based approach. Okay, so in order to do that, the first thing is that you need to represent every sequences by its polynomial form. That is, if you have the g of 1, right? What is g of 1? G of 1 is equal to 1 comma 0 comma 1 comma 1. This is called as g of 1. Okay, so in that case, g of 1 of x is equal to 1 plus 0, so there is no x square plus x cube, right? Now what is the next value? Is g of 2. So what is g of 2? G of 2 is 1 1 1 1. So we all know it's polynomial. Very easy, right? 1 plus x square plus x cube. Okay, that is the coefficient of this all the coefficient of x square and x cube and x raised to 0 and all are depending on the values of the sequences. Okay, so here if you can see over here, the coefficient of x raised to 0 is 1, the coefficient of x is 0. That's why I'm not writing x over here, because 0 into x is 0, so I don't have to write x over here. The coefficient of x square is 1 and the coefficient of x cube is 1. Likewise, same way over here also. Okay, next I'm going to write we all know the information sequence is 1 comma 0 comma 1 comma 1 comma 1. All right, 3 ones. So 1 0 1 1 1. So you all know how to write the u of x, right? Very easy. U of x is equal to 1 plus, there is no x square plus x cube plus x raised to 4. This is u of x. So that's what it is. So first thing, you represent every sequence by its polynomial form. Then what you do is you simply apply the equation which you already know that you have been applying it since the NK linear block code. That is, if you want to find the value of v of 1 of x, if you want to find the value of v of 1 of x, simply multiply u of x with g of 1 of x. Okay, if you want to find the value of v2 of x, you need to multiply u of x with g of 2 of x. Okay, and then so like that you can find the value of v of 1 and v of 2. Like that you can find the v of 1 and v of 2. So once we found the v of 1x and v of 2 of x, then you have found both the polynomials. Once when you find the two polynomials, then you can find its sequences, and then you can then combine the sequences to find the value of v. That is one way of doing it. The other way of doing is that you can find v of x. That is the polynomial of the output. Okay, so what is the output polynomial? What is the output polynomial? Output polynomial means the polynomial of the output signal itself. That is the combination of v of 1 and v of 2. Okay, so how to write the v of x? Before writing the equations, I will explain to you why the equation is like that. Okay, so v of x equation, the equation of v of x depends on what kind of a multiplexer you are using. You see, if you look over here, the switch changes alternatively. The position of the switch will change. First it will be over here, then it will be over here, then it will be over here, then it will over here, right? So which means there is a delay. That is, when the switch is in position 1, okay, or when it is taking the value of v of 1, and after a delay, that is, after going to position 2 only, it will take the next value of v of 1. You see, so which means that means since this is a 2:1 mux, okay, since there is a 2:1 mux, every alternatively only you will get the value of v of 1 and v of 2 combined in the output signal. So which means if you want to write the equation of v of x, that is the total output signal, you need to express this in terms of, v of x in terms of v of 1 of x square. V of 1 of x square. Okay, that is why instead of v of 1 of x, you need to express this in v of 1 of x square. So v of x is actually a combination of v of 1 of x square and v2 of x. So v of 1 of x square plus, if you want to combine both of them, it will be x into v of 2 of x square. X into v of 2 of x square. This is how we write the output signal. This v of x is equal to v of 1 of x square plus x into v of 2 of x square. Okay, this x is used over here to join v of 1 of x and v of 2 of x, because the first output is when you are writing the numbers, right? This is how it will be represented as. So this is the second underline over here is v of 2 of x, and the first one is v of 1 of x. So if you want to write both of them, you need to join them together. Okay, and that's one thing. And also, since this is v1 of x, then the next one is also the alternative, only the v of 1 of x is present, right? Over here, and over here. So therefore, that's why I'm using x square. Same case over here also, v2 of x square also. Okay, so this is how we represent the equation. So let's do this problem. So here v of 1 of x is equal to, what is u of x? This is u of x, 1 plus x square, 1 plus x square plus x cube plus x raised to 4. Okay, and what is g of 1 of x? g1 of x is 1 plus x square plus x cube. 1 plus x square plus x cube. Okay, now let's multiply them. So you will get 1 plus x square plus x cube plus x square plus x raised to 4 plus x raised to 5 plus, here it will be x cube plus x raised to 5, x cube plus x raised to 5 plus x raised to 6 plus x raised to 6 plus x raised to 4 plus x raised to 6 plus x raised to 7. Okay, this is it. Now we all know this plus actually represents nothing but the XOR function, which means if you see the same degree of x anywhere, you can cancel both of them. Okay, so that's what I'm going to do. So here let me see if there is any same. Yeah, see, x square and x square. So because x square plus x square, the reason why you're cancelling is because x square plus x square is equal to x square into 1 plus 1. This plus actually represents XOR function, okay, or modulo 2 sum. That is why when 1 plus 1 is equal to 0, that is why this is equal to 0. So if you see any same degree of x anywhere, you can cancel each of them. So here x square and x square, cancel them. Is there anywhere else? Yeah, here x cube and x cube will cancel each other. X raised to 4 and x raised to 4 will cancel each other. X raised to 5 and x raised to 5 will cancel each other. X raised to 6 and x raised to 6 will cancel each other. Therefore, there's no other same value, right? So which means the answer is 1 plus x raised to 7. Okay, or in other words, v of 1 is equal to 1 comma 0 comma 0 comma 0 comma 1 2 3 4 0 1 2 3 4 5 6 7. Okay, 0 1 2 3 4 5 6 7. This is the value of v of 1. Okay, if you compare this answer with your previous answer in the previous video, you'll see that both the answer are exactly correct. Okay, now let's look at v of 2 of x. V of 2 of x is equal to, u of x is this one, 1 plus x square plus x cube plus x raised to 4, and g of 2 of x is this one, 1 plus x square plus x cube, 1 plus x square plus x cube. Okay, so now I'm going to multiply them, and this will become 1 plus x square plus x cube plus, and this will become, multiply this, it will become x square plus x cube plus x raised to 4 plus x raised to 5 plus x cube plus x raised to 4 plus x raised to 5 plus x raised to 6 plus x raised to 4 plus x raised to 5 plus x raised to 6 plus x raised to 7. Okay, let's begin. So here also we'll learn, we need same degree, we can cancel each other. X square and x square, x cube and x cube, x raised to 4 and x raised to 4, x raised to 5 and x raised to 5, x raised to 6 and x raised to 6, and x raised to 4, No, there's no x raised to 4 anymore. Is the x raised to 5? No, I don't see any x raised to 5 over here. Is the x raised to 7 anywhere? No, I don't see any x raised to 7 anymore. I don't see 1, I don't see x, I don't see x cube. There is no x cube also anywhere over here. So which means the answer is 1 plus x cube plus x raised to 4 plus x raised to 5 plus x raised to 7. This is the value of v of 2 of x, or in other words, this can also be written as, let me see, 0, no sorry, this is 1, right? So 1 comma 1 comma 0 comma 1 comma 1 comma 1 comma 0 comma 1. 0, 1, 2, 3, 4, 5, 6, 7. This is the value of v of 2 of x. Okay. So now the answer, if you want to write an answer, you can write the answer directly now itself. But I just want to explain to you how to write the output sequence looking at the output polynomial. Okay. So here, if you want, you can write the answer. So here the answer is, let me see, what's the answer? 1, 1, comma, 0, 1, comma, 0, 1, comma, let me see, 1, 1, 0, 1, 0, 0. This is 0, 0, comma, 0, 1, comma, 0, 1, comma, 0, 1, comma, 0, 0, comma, 1, 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Exactly. Okay, so this is the equation, right? So this is how we write them. Okay, so now why are there 8 values that I forgot to mention? Why are there 8 values? Because the length of the information sequence is equal to 5. The length of the information sequence is equal to 5, that is capital letter L. L is equal to 5, and also the number of shift register block is equal to 3, that is M is equal to 3. So therefore the total length of the sequence will be 5 plus 3, which is equal to 8. Okay, this is the answer. So if you compare this answer with your previous answer, you can see that both of them are exactly equal, right? But still, okay, I want to tell you how to write this. That is the output polynomial. It's a polynomial of v, right? And the way how to do that is, first you express v of 1 in terms of x square. So what is v of 1 of x square? V of 1 of x square is equal to 1 plus x raised to 14, right? Because reason is v of 1 of x is equal to 1 plus x raised to 7. So which means if you are going to express in terms of x square, you need to replace every x with x square. So if this is become x square, this will become 1 plus x raised to 2 the whole raised to 7, which is nothing but 1 plus x raised to 14. Okay, that is how we write. Which means you need to multiply every power by 2. That's all. Multiply every x, the power of x, with 2. That's all. So here, what is v of 2 of x square? V of 2 of x square is equal to, this is, here you see 1, so it is 1 plus, here you see x, so this it becomes x square, plus here you see x cube, so this will become x raised to 6, plus here you see x raised to 4, so this will become x raised to 8. Here you see x raised to 5, so it will become x raised to 10. Here you see x raised to 7, which will become x raised to 14. So this is v of 2 of x square. Okay. Then what I'm going to do is I'm going to multiply this with x, because that is the second term. The second term is like that. Okay. The first term I have already got over here. The second term is this one. So which means I need to multiply this again with x. Okay. So that will save my time. Lot of time. So this will become vx into v of 2 of x square. Or you do something. No need to multiply. Write the answer directly. Then it will be, I think that will be easier for you, right? V of x is equal to v of 1 of x square plus x into v of 2 of x square, right? So what is v of 1 of x square? That is this one. 1 plus x raised to 14. Okay. Plus x into, here you have 1 plus x square plus x raised to 6 plus x raised to 8 plus x raised to 10 plus x raised to 14. Okay, so when I go multiply it, I'm 1 plus x raised to 14 plus, this will become x plus x cube plus x raised to 7 plus x raised to 9 plus x raised to 11 plus x raised to 15. Okay, we rearrange it in the ascending order. This will become 1 plus x cube plus x raised to 7. Okay, plus you have x raised to 9, x raised to 9 plus then you have x raised to 11 plus x raised to, after x raised to 11 it is x raised to 14, right? X raised to 14 plus x raised to 15. Okay, so this is your answer. This is v of x. Or in other words, v is equal to 1 1 comma 0 1 comma, all right, 0 0 comma 0 1 comma 0 1 comma 0 1 comma, let me see, 0 1 2 3 4 5 0 1 2 3 4 5 6 7 8 9 10 11 12 13, then you have 14 15. Okay, this is the value. If you compare these two answers, both of them are exactly the same, right? Now, one thing you need to understand is that the reason you are able to do this, or one thing you need to understand is that you have been able to write this equation directly. Okay, the reason why this is very easy for you is because there is only one input, right? Only one input. Since there is only one input, it is very easy to write the equation in terms of that input, right? All you need to do is multiply that input with the corresponding sequence. If you want v of 1 of x, multiply it with g of 1 of x. If you want v of 2 of x, multiply it with g of 2 of x. But that won't be enough when you are applying a convolution encoder having more than one input. Suppose if this had been 2 2 3 convolution encoder, 2 2 3 convolution encoder means what? It means that there are two inputs, okay, and there are two inputs, and each input will be having 3 shift register blocks. That makes 6. So there will be 6 shift register blocks. So in those kinds of cases, it will be very confusing to apply this equation. For that only, we apply, or we use what we call it as g of x. Now, what is g of x? G of x is called as the system transfer function, okay, or simply transfer function. G of x is called as the transfer function. Okay, we make use of this matrix. Okay, it's actually a matrix of polynomials. So what is g of x is? G of x is a, I hope you already understand the easiness behind this. G of x is actually a k by n dimension matrix. A k by n, just like the same g that you have been using from the cyclic code, that same geometry matrix. But this time it is only in terms of polynomial. That's all. So here this is g of x, and here it's a k by n. K by n means the number of inputs is the number of rows, and the number of output is the number of columns. And the value of the g of x is written like this. That is, g of x is equal to, so here this is, if you look over here, this is actually, okay, I'll generalize and write it. So g of x is represent like this. That is, this is g1 of 1 of x, this is g1 of 2 of x, this is g1 of 2 of 3 of x, it goes on, and the last column will be g1 of n of x. Okay, and downwards will be the number of inputs. That's g2 of 1 of x, this is g3 of 1 of x, and it goes on, and the last will be gk of 1 of x. Okay, same way over here also, g2 of 2 of x, this is g3 of 2 of x, and it goes on, and the last column will be gk of gk of 2 of x. Over here we have g2 of 3 of x. This is g3 of 3 of x. It goes on, and the last column will be jk of 3 of x. Okay, and this goes on. The last column, in the last column, the last row element will be here. It will becomes g2 of n of x. This is g3 of n of x, and it goes down, and the last column will be jk of n of x. This is how this is what you call as the transfer function of the convolutional encoder. This is called as the transfer function. You see, you can represent here, you can represent any sequence in terms of its input and its output, right? In terms of output, we represent it in every row, and in terms of the input, we represent in every column. That's why the number k by n, number of rows is the number of inputs. So you see 1, 2, 3, 4 up to k. That's why there are k inputs. Okay, and the number of output is equal to n. That is why g of 1, g of 2, g of 3 up to g of n. So therefore the last column will be g k of n, right? So this is how this is called as the k by n system transfer function. We represent it using this function. For example, in this example, right, in this problem, in this 213, g of x is represented like this, right? This g of x is equal to, here the value of k is equal to 1, the value of k is equal to 1, and the value of n is equal to 2, right? Which means we have a 1 by 2. And how do you represent 1 by 2 matrix? That is like this. That is g of 1 of x, g of 2 of x. This is how we represent the function of this example, right? Or in other words, g of 1 of x is equal to 1 plus x square plus x cube, 1 plus x square plus x cube, comma, and g of 2 of x. G of 2 of x is 1 plus x square plus x cube. 1 plus x plus x square plus x cube. This is how we represent the g of x of 213 convolution encoder. This is called as g of x. Okay, so and then how do you find the value of v of x? By multiplying capital V of x. Okay, capital V of x, we multiply capital V of x with is equal, we find the value of v of x by using v of x is equal to u of x into g of x. Okay, u of x into g of x. So like that you get the value. So in that case you will get the value of both v1 of x, and also you will get the value of v of 2 of x. Okay, this is how this is one way of doing transfer function. We will do that in the next example. Okay, in the next example we will be using this matrix to solve it.